And welcome everybody to the Daily Space Weather Show. It's the Smash News Network, least busted name of news, once again bringing you the world's most comprehensive daily space weather content and detailed solar imagery. It's exciting times to be doing space weather. Let's take a look at some gear. These are 24-hour videos. SDO 304 plus 193, 60-minute running difference. Great at showing solar filaments, active regions, and a bit of the extended corona in that difference imagery. And the top story will remain Sunspot 3590, which is that large sunspot moving right into the Earth-facing zone there above our Earth scale. And we've rotated the field of view with the imagery here to allow that to appear stationary. It's just, again, the field of view rotating here with the imagery to show you these extreme close-ups. And we've got plenty more for you. Haha, so don't worry. And yeah, not half bad. That is the SDO magnetogram plus 171 angstroms. And we still do have a very high likelihood of X-class solar flares. So we'll talk more about that here in a moment. First, a quick 48-hour video. That's SDO 335 angstroms. And a couple of large solar flares mixed in there. I believe that's 2 X-class events in the past as many days. So several new sunspots there recently rose around the eastern limb. I think they might have actually exhibited some growth also. We'll take a look at those as well here momentarily. First, a brief look at planet Earth. So, of course, you've got to check out what's going on planet Earth, folks, right? So, volcanoes are next. These are the erupting issues. By the way, another impending eruption expected at Reykjanes. We're expecting to see some lava fountaining and some basic outgassing and lava flows. So a couple different scenarios may play out there, expecting as much as 5 million cubic meters of lava to have amassed below the area around Grindavik. So very likely for another eruption to happen there. Also Sakurajima exploding, Subanosejima, Mount Manam, Luatobe. Also Luatolo, Semeru, Dacono, Popocatépetl, Sancho Guido, Fuego, Nevado del Ruiz, Revenador, and Sabancaya, all erupting. Also the 7 and greater magnitude earthquake drought continues, folks. So yeah, there's that. There's the 90-day bar graph, and yeah, it's an earthquake drought. Earthquake droughts and earthquakes. Remember, folks, any earthquake can be a foreshock. It's been quite a while since we had a 7 or greater magnitude event. So here are the last 24 hours. We'll call out 5 and greater magnitude quakes. China had a 5.0 late last night. Japan had a 5.3 late last night. Indonesia had a 5.2 early this morning at 00:51 Universal Time. Taiwan had a 5.0 a few hours later at 4:37. Japan had a 5.1 at 17:40. I'm sorry, make that 10:17. 10:17 Universal Time. The 5.1 at Japan. Vanuatu had a 5.0. And then only 10 minutes after that, on the other side of the Pacific, Nicaragua had a 5.3 near El Rielejo. El Rielejo, I guess it would be pronounced. That 5.3 was at 21:57 Universal Time this evening. And let's get back to some space. Space, a frontier. These are the voyages of the 10.7 centimeter radial flux, which is now back up to 179 solar flux units. 179 for the radial flux. And there's the 1 year graph of it. Represented by the black line, you can see the steady upswing for the past 5 months or so. That is the slow ramp up to solar cycle 25 solar maximum. So it's exciting stuff. Expect another 16 months of solar activity at the levels we have now, if not a little bit higher for a large portion of that period. And we've got some space weather coming tomorrow, so likelihood of a geomagnetic storm is quite high. NOAA, Tamitha Skov, and our channel all agree on this. So also NASA is on board. So nobody is in disagreement about this that I'm concerned with. So Tamitha Skov, NOAA, NASA, and I all agree. That's a good sign for geomagnetic storms. So possibly by tomorrow's video, we'll be doing a video during a geomagnetic storm. More on that in a moment. First, the last 4 hours of Earth's magnetic moment from space. Our geospace magnetosphere movie. This model depicts magnetohydrodynamic pressure. If you're measuring magnetohydrodynamic pressure, the units are nanopascals. So that's what's going on. The past 4 hours of Earth's magnetic moment from space, geomagnetically calm conditions. Next, Earth's magnetic moment from the ground. This is depicting magnetic flux density, a different measurement, a different set of units the model is projecting. That is the space weather modeling framework that does the projecting, and the units here are nanotesla. That's magnetic flux density at the ground level. Now, you can use this map, by the way, tomorrow for geomagnetic storm forecasting. Another thing you can use, as well as this geospace magnetosphere movie map, you can check out the magnetic perturbations on a global scale for North America or for the whole world scale. And if you want to check out another one that's also good for the likelihood of aurora in your location, try the geoelectric field map. So that is right here, the geoelectric field model for US and Canada. That can also help you find out where you could expect to see the aurora. It'll show you actually grid induction. So we're not expecting that to light up now, but tomorrow night we might see quite a bit of lighting up of that. So another way you can sort of try to determine where you may be able to see the aurora. Keep in mind these things come and go rapidly. The geoelectric field map for US and Canada. KP is 2.33. 2.33, folks. Again, it is a geomagnetically calm scenario at the moment. We're expecting this to be as high as KP6, but I would say probably more like a KP5 or less from the somewhat glancing blow we're all expecting to arrive sometime after midday tomorrow on February 25th, exactly as we forecasted only hours after the CME happened on the late in the day on the 21st. So anyway, moving along to our solar wind data, we've got, there's the ACE. That's not the ACE. Hold on a minute. Let me get the right, there we go. Get the ACE loaded there. There is the ACE, showing about 3.5 protons per cubic centimeter for solar wind density. Solar wind velocity here, 365 kilometers per second. As for the Discover, a little denser solar wind and a similar speed. So about 9 protons per cubic centimeter for the solar wind density there at Discover. And about 370 kilometers per second for the velocity. The higher speed wind has ramped down, folks, and we're at now a solid signal now at a lower plasma temperature. It looks like a coronal hole high-speed stream has subsided. We are expecting another one in 2 to 3 days. So that should be following the CME impact. 2 to 3 days, sometime on the 26th or 27th, expecting a coronal hole high-speed stream to show up. And next we'll look at the GOES magnetometers. And we saw a little higher readings there happening for both magnetometers around noon local time for the satellites, which is what these N's are standing for right there. Those N's, that is noon local time for the GOES 16. And the GOES are in a geosynchronous near equatorial orbit. They're in the outer portion of the outer Van Allen belt at about 23,500 miles of altitude. Next, we'll do the heliospheric sector magnetism, and Earth remains in a South Pole magnetic heliosphere sector. Could be as many as 2 more days that we stay there. Keep in mind the magnetic environment can change with basically no warning. Next, line of sight field plot, and that's photosphere magnetism in grayscale, solar B field in blue, and the potential field surface source lines in red and green are the polar fields. South is red and north is green. No, I'm not blue-green colorblind. I just said the wrong color. So next we'll move to coronal hole line of sight field plot. And you may or may not realize that one of my skills is the ability to go from completely serious to completely silly with absolutely no warning or delay. So there's our line of sight coronal hole field plot. And South Pole coronal hole here should provide, like we said earlier, a high-speed coronal hole wind stream in a couple of days. Let's take a look at coronal holes from SDO. So there you have it. And let's move to sunspots. Now we're going to talk cosmic rays briefly on this video also, but first sunspots. Sunspot number here did not come up as we expected, so some of those sunspots in the east must have already been counted at yesterday's video. Sunspot number actually came down a little bit, so current number is about 105, about 105 sunspots, and we'll show you whether there was growth or decay in the past 24 hours momentarily here. But first, let's talk about the relationship between cosmic ray flux and sunspots. So they are inversely proportional things, folks. When you see higher cosmic ray flux, you see lower sunspot numbers, and vice versa. So all of these spikes in the historic data from Oulu, Finland's neutron monitor. This lower pane down here, let's actually switch to the full screen mode. So this lower pane down here, it is showing you here that the cosmic ray flux has not been at these levels since approximately 2004. So there you can see that dotted line there. 2004 is the last time we saw cosmic ray flux this low. So at about a 20-year low for cosmic rays across all reliable monitors. So there we're showing Oulu, Finland. And as you can see, the past 30 days have been slightly up, almost flat for the past 30 days at Oulu. DOMB is down over the past 30 days. DOMC Antarctica also flat over the past 30 days, maybe a slight uptick there. It's close. We'll also show Mexico City, which is flat over the past 30 days. We'll show Athens, which is all over the place. Let's ignore that one. And then we'll show Apatity and Barentsburg. So Apatity is a slight uptick over the past 30 days, and Barentsburg a slight downtick over the past 30 days, almost flat. So those are your cosmic ray reports. And again, just a quick reminder, folks, cosmic ray flux is inversely proportional to sunspot number. It's because solar plasma has a tendency to act like a shield. It adsorbs, refracts, etc. the cosmic rays from reaching Earth. So again, lowest levels in the past 20 years. And as far as a cosmic ray flux forecast, we are expecting a downtick in cosmic ray flux for the next approximately 20 months. So we can expect about 2 years of lower and lower cosmic ray flux. So this is just how solar cycles work. This is just based on the way the solar cycles have been quite similar for at least 1,000 years, probably more like several million years. Cosmic ray flux and sunspot number are inversely proportional. So we keep hearing people say, oh, energy from space is increasing, it's very spooky, and 20-year low in cosmic ray flux. So I don't know what energy they're talking about, but generally in science, we don't just say the word energy. You don't just say energy from space is increasing. You say solar X-rays are increasing as we approach solar maximum, or there are more coronal mass ejections, or there are more cosmic rays getting measured. Like energy from space, that is not science terminology. Anyway, Tamitha Skov will probably agree with what I just said, but I'm not going to ask. If you haven't been watching her forecast, like I said earlier, she agrees with ours. Oh, and look, folks, Tamitha must agree that the Earth is shaped like a croissant. Look at this graphic right here, right there. Boom. Croissant-shaped. Look at that. Just slipping it in there like a subliminal message. Clearly, planet Earth is croissant-shaped. Here's a clip from her video today.
Have a bit of storming on the 24th.
So there you go. Make sure you watch her channel. If you don't otherwise, Tamitha Skov, Space Weather Woman. She is a delight. And yeah. Now, let's get to our Ask a Particle Physicist segment for today, featuring Eugene Bagashov, another channel that you ought to subscribe to. If you haven't already done so, make sure you subscribe to Eugene the Philosopher. We'll tell you more about that here in a moment. And let's allow the magician from Minsk to take it away. So take it away, Eugene Bagashov. Bagashov. The magician from Minsk. Here he goes.
Okay, boys and girls, let's explain the different hypotheses of what stars are made of, how stars work, etc. and tell my favorite hypothesis and why it's my favorite. Well, you know, like this might be problematic because, you know, that's quite a bit hidden in this etc. You know, it's like many PhD dissertations, many books, millions of articles. You know, I don't think I can explain this. But anyway, like different hypotheses. Let's start with this. Well, there's a very simple one which we may call, actually let me write this down here, gaseous, right? Gaseous hypothesis, which states that the sun, it's so hot that it cannot possibly be solid or liquid, so it has to be a gas. So it's a gaseous plasma, supposedly again, mostly hydrogen, supposedly again. So inside of it, it's very dense because like the pressure is very high, etc., etc. So thermonuclear fusion happens there. So the energy starts creeping upwards from there. You know, it's firstly emitted in the form of like gamma rays, and then it starts to being absorbed and re-emitted, etc., etc. And when it goes to the surface layer, it's kind of emitted as the visible light, right? Something like this. Then we have like the systems of electric currents inside the sun that creates, you know, the dynamo, so-called in air quotes dynamo effect, which creates the magnetic fields, and that's what produces what we observe more or less in the gaseous model of the sun. It has a lot of problems. I'm not gonna lie, like so many problems I can't even possibly list them here. But this is the model, and this is how stars work in this model, all right? Hopefully this is understandable. Then we have Pierre-Marie Robitaille's liquid model, which states that the sun is probably a liquid metallic phase of hydrogen. So it's also hydrogen, just like in gaseous model, but it's a liquid instead of a gas, all right? And it has certain advantages in terms of, like in comparison to gaseous model. I don't think Robitaille ever touches on the topic of magnetic fields, even though I think this is an essential part of the sun, like how magnetic fields are produced, like how should we modify our dynamo models with respect to gaseous, you know. I think he says that in order to sustain the dynamo, you have to have like some sort of framework, so some condensed matter should be present in order for the dynamo flows to flow in, so to speak. So in this sense, maybe you can claim that he addresses this issue, but I'm not sure about this. I mean, ask him again. How stars work in this model? Well, I mean, they're just liquids, okay? Like that's the only difference. It leads to certain possibly observational differences, right? Different explanations for the same observables, rather, as in gaseous model, but yeah, that's kind of the difference. Then what do we have? solid sun models or star models. You probably never heard about them, and there's only one example I'm aware of. There's a guy named Michael Mozina who has been somewhat active on the Thunderbolts project forum some years ago. Like last time I talked to him was maybe 2021, something like this, so it was quite a while ago. But he was much more active before that. So at some point, I'm not sure he still thinks this, but he claimed that the sun is probably like a ball of iron, essentially, like a solid ball of iron, and all the surface activity that we see is due to some, electric currents flowing on its surface and stuff. Like, whether you like it or not, like, I'm not sure how well developed this model was, and how stars work, as we say here in this model, but at least it's a model. Okay, you can say, well, okay, let's imagine the sun is a solid ball of metal. What happens then? Well, this is a hypothesis. Okay, so you can maybe develop it if you like. Yeah, so these are probably the main ones. And what is my favorite? I'm kind of on the fence, to be honest. Like, I don't really enjoy all of these too much. Like, this one is kind of interesting because it's like somewhat better than this one, but at the same time it's more developed than this one, so it's kind of like, it's something might be found here potentially, but obviously, I mean, hundreds of people need to work on its development, and right now it's probably Robitaille and maybe like a dozen enthusiasts, I don't know. So yeah. There you go. So I don't really have a favorite one. And look, this is such a narrow view, right? So if we're talking about like philosophical terms, like these are different states of matter. Like, who says that the sun is made of matter in the first place, Like, who says the sun is made of chemical elements? Like, it's such a big leap to say that whatever we get in the lab is the same stuff we see in the sky. Like, like, speaking very abstractly, very, very, very generalizably, how are we so sure that the sun is made of everything that we see around us on Earth, for example? I don't know. Like, the sun may neither be a gas or liquid or solid or even a plasma, if you wish. Maybe the sun is not a plasma in the first place. I don't know. Look, we only observe like 1,000th of a percent of the solar volume, right? The uppermost layer. Same is true for Earth, by the way, but a little bit better percentage. But the point still stands. We have no idea what 99.99999% of the sun looks and behaves like, right? Because we don't see it, and we have no instruments to interact with it in any way. So this is all like speculation, a pretty wild one, I would say. So out of these three, definitely liquid. Out of the model, the possible hypotheses of the stars and the sun, it's probably neither of these, honestly. Like, Kozyrev had the hypothesis that stars produce energy by some completely other method, that they're kind of absorbing time, and I'm speaking like very, very abstractly, like philosophically speaking, okay? And you may say it's kind of crazy, it sounds stupid, but think about this. I'm not sure if you're aware of this factoid, but just ruminate on this this evening, okay? So the density of energy that the sun emits per unit of mass of the sun itself is lower than the density of energy that the rotten leaves emit. So it's a very small amount of energy that the sun emits per unit of mass. Like, it's very calm and dormant. It's basically kind of cold in this sense, It's like rotten leaves level of cold. And the human body emits like 2 orders of magnitude more than the sun per unit of mass. So if you make a sun out of humans, it would, I don't know, it would burn all the planets, okay? So there you go. These are the hypotheses, and I'm kind of, I feel that this is too narrow. I feel that, I don't know, like a complete reevaluation of everything is needed, but then I'm just a rogue philosopher. I'm not really a scientist per se, even though I was one, okay?
All right, so there you go. There's our Ask a Particle Physicist segment. It usually shows up on a Friday, but there was a delay, and the reason is classified. So, again, make sure you check out Eugene the Philosopher's channel on YouTube, Eugene the Philosopher. Thanks for doing the Ask a Particle Physicist segment. We'll typically feature that every Friday. And we just premiered last week's. The Smash Team paid members get to see the standalone session first, but you can see last week's at our playlists at youtube.com/smashomash/playlists. So yeah, Eugene the Philosopher, thanks again to the magician from Minsk. We've got some issues with some ISWA sites, so we'll skip that and move on to the GOES proton flux. But first, we'll look at sunspots. I guess that's kind of important, right? So there you go. I guess most or all of those new sunspots in the east have been counted. And, I guess I should probably actually show them. There we go. That's better. All right. So that's what you want. And do we see any major changes? Not so much. I think there's a little bit of growth in the northeastern sunspot group. There is at least one more sunspot about to rise. Oh, we do have one at higher latitudes that's also forming. I think there's a new sunspot up here also. I think that one may have just formed. Yeah, that one's formed in the past 24 hours, I think. So now we have 4 on the east. This one's also getting some leaders up here to its northwest. So it looks like a little bit of an uptick there. Now let's look at some extreme close-ups. And now we've once again rotated the frame of view. So now that appears stationary. Of course, the sun is still rotating, but the frame of view is traveling with the sunspots. So you can see the evolution as it stays, quote, stationary from your perspective as the field of view rotates along with the sun. So just spectacular imagery there. And some new volatility just happening once again in the last few hours in sunspot 3590's leading most northwesterly umbra, or I should say the farthest north umbra. So here you can see that happening. That's a series of magnetic fields there, all stacked on top of each other. And that is an extremely volatile region of a sunspot. So anyway, the likelihood of X-class flares remains, and we are seeing some significant magnetic shear forming in some of these areas here. So that sunspot remains quite volatile indeed. Here we've added the 171 angstroms wavelength to it. And there is 171 plus continuum. All right, so as far as energetic particles, we ain't got none. Not yet. 2 M-class flares in the past 24 hours. 2 M-class events. Let's take a look at those from SDO. They were both in the north and the northeast. And of course, the likelihood of X-class flares remains. Here's a close-up in 94 angstroms of Sunspot 3590. It has been quite the sunspot. Once again, the field of view here rotating with the sun to make it look stationary. Also 131 angstroms. There are some large plasma filaments around that sunspot, which we would not be surprised to see blasting off in the next 24 hours also. So, likelihood of solar flares not only very high, but also likelihood of coronal mass ejections very high, since we saw 3 X-class flares and almost no ejecta coming out them. So, once again, another great time to reiterate the fact that solar flares and coronal mass ejections are completely separate phenomena, I should say. and should not be conflated, as they are very different things. We see flares regularly with no coronal mass ejections, and we see coronal mass ejections regularly with no flares. So this is a perfect example of the former. 3 large solar flares and no significant ejecta. Well, one CME, but of course the one that's headed to Earth for tomorrow was not from 3590. So continuing on to a star chart, we like to show our viewers what's going on overhead at our location. Is it full moon day today? I think it's full moon. Pretty close. I think it's full moon. Anyway, that's what's going on. If you're viewing the early night sky, you'll see Jupiter still hanging out there. It'll be there for quite a while, as all the planets are on the other side of the solar system from us, folks. So here's your solar system forecast through March 2nd. We'll have a gibbous waning moon by the 2nd of March. Let us know in the comments if you think it'll come in like a lion and go out like a lamb. Of course, our astronomy photo of the day is the first private moon landing. Don't worry, folks, it was unmanned, but it was quite successful. The Odysseus mission by Intuitive Machines, the apod.nasa.gov astronomy picture of the day. And we'll move on to CMEs, and it's hasn't been super exciting. So there's George Mason University's data. That's 80 frames from today. We've got a little additional stuff here, but let's just switch to our fantastically our fantastically custom videos. So yeah, CME activity pretty light here for the past 24 hours. We've synced the SDO LASCO C3 and C2 there for you. And doesn't look like any earthly directed events to me. Here we've subtracted the C3 and added the SDO 193 angstroms 60-minute running difference. Crown prominence is at both poles, and you can expect to see that type of behavior continue as well, a feature that you're likely to see around solar maximum, and we're still 8 months out from that, most likely. More 24-hour videos here. We've zoomed in one more step to show the full disk. And here's an even closer view for you. We've come full circle, folks. Full circle. Note this massive filament setting up here in the northwest. It is really huge, and it's starting to become a prominence as we make the video. Get a great side-on view of the southwestern edge of that filament there, as it again becomes a prominence. Filaments and prominences are the same feature. Anyway, we've got some missing panes there. We'll ignore those, and we'll move on to show those filaments. So here is that filament becoming a prominence from Cerro Tololo, Chile. And that one could still get a name. Don't be surprised to see that one go blasting off, by the way. If it does so, even on the far side, most likely we'll be able to see it happen on the channel. Perhaps name that filament after somebody you'd like to see go away, because it is going away from becoming likely to produce any earthly directed CMEs. So here's an even closer view of it. In the colored imagery, it's not going to show it as a prominence, but you can see how three-dimensional that is. Really several hundred kilometers tall there, that filament. So lots of filaments right now on the Earth side of the disk. And again, you can see some important ones here around this sunspot 3590. That is some space weather. Again, crown prominences, very high likelihood of X-class solar flare events. Let's get the bonus features. I've vanished. And now I'm back. All right, there are the past couple of hours. Looks like a flare is just kicking off here recently. Looks like some kind of event is happening as we make the video. All right, check it out. All right, so let's continue on here. Bonus feature, satellite charging hazards, just some minor surface charging there. Low energy electrons building up on the outside of spacecraft in places like the Middle East. Goes electron flux here. Quite low, quite low. There's the 1-year graph from solon.info. Forecast model showing a downtick. That would be consistent with a CME impact. So agree with that forecast. If you disagree, let us know in the comments. Keep in mind that will be an anomalous reading, but it will still show as a dip. That is a normal thing that happens during CME impacts and coronal hole high-speed streams. Geomagnetic storms. So, next the ionosphere, and here it is. And it's pretty nominal. It's pretty uneventful. There's the anomaly in megahertz from the 30-day median. Could you get me a club soda? Hook me up with a club soda. I'll give you $1. So, actually a bit of red there. So, a bit of low-frequency anomaly showing up on the ionogram. That's the anomaly in megahertz from a 30-day median. We're seeing a little bit of ionosphere activity happening there. But nothing looking like a geomagnetic storm. We also like to show the global ionosphere nowcast. Thank you. And we end the space weather content with the latest high-res images. We show you the refresh happen, and there you can see that volatile region. So you can see the magnetic shear inside of that umbra. That is pretty spectacular as far as solar flare risk. So that is a good one. Even though it's shrunk, there is still a lot of magnetic shear. Let's briefly take a look at these. Bunch of new sunspots there in the east. That one's beta class. That one's beta gamma class. And that one's beta gamma class. I think we may have a modest bit of growth there. Yeah, that one looks like it has some new accompanying umbrae that are looking to form, perhaps. And let's move to meteorology, as we don't want the video to be too lengthy. Check it out. This area here, that is... Anybody want to guess where that's located? That right there is the world's highest sustained winds and highest seas. But the seas are not very stormy, folks. It's pretty good times to be sailing right now, as the highest seas in the world are only like 26 footers. So not a lot of sustained winds or big waves anywhere in the world. So there you go. That's what's going on. We've got calm seas. If you have to be frightened of something, you can assume that that's the calm before the storm. One man, one star. The Smash News Network. Least busted name in news. Here are the surface winds of the eastern world. And here are the jet streams. Jet streams of Europe, Africa, and the Middle East. And the surface winds. Surface winds of the Americas. And the jet streams. Clouds and fog. It's shortwave radiation. It shows you clouds and fog at nighttime, baby. Thinking about going out to see the aurora? You want to be able to forecast whether it's going to be cloudy or clear? Shortwave radiation map. Impress your friends and foes with accurate weather forecasting. There are clouds on windy.com also. Would you like to be able to know ahead of time if you'll be able to see the aurora? Well, try forecasting using these things. If you're unable to look at the data and forecast yourself, check it out. You can even advance when windy expects there to be clouds and not clouds. Just select clouds and then advance it. You can even look at different models. There's the GFS model. Will it be cloudy tomorrow at 10 a.m. in Pennsylvania? Nope. But by 11, it'll be... Anyway, that's the point. You can... If you don't know how to forecast by looking at the data, you can put models together. We usually just show the data, but we do show some models as well to summarize things, because I don't do ultra precise forecasts in ultra tight locations unless I have a reason to, like a Sherpa. So, but there's the U.S. government, the National Weather Service map, and those are the warnings. So next are the forecasts, like the GFS 72-hour pressure and precipitation forecast. That's the model. There we go. Now it's bigger. It's bigger, and it's probably even better. So yeah, there you go. There's the U.S. lower 48, at least, GFS 72-hour model. A bunch of snow is going to make its way down the Rockies, and then some more rain is going to hit California. A very moistened state. Listen, strange women lying in ponds distributing swords is no basis for a system of government. Supreme executive powers derive from a mandate from the masses, not some farcical aquatic ceremony. There is our jet stream forecast for the next 72 hours. Strange women lying in ponds distributing swords is no basis for a system of government. Temperature anomaly forecast is our last forecast, as warm weather sweeps across, starting with the Mississippi Valley. and then making its way to the entire eastern portion of the country. As another cold wave follows it, intruding from Canada. Crispy, gross, frozen air from Canada, which smells of maple syrup. Maple syrup and burned maple trees, as it were. So yeah, 72-hour temperature anomaly forecast. It's in degrees Celsius. Anyway, what else we have? Lightning, and it's pretty weak right now. The U.S. ain't got no terrestrial strikes. Let's skip it. Let's move on to Doppler radar, and Alaska's got some stuff showing up in some fairly unpopulated areas. So here are the full 50 states view. There you go. Here are the lower 48 view. Clouds and fog. And water vapor. And here's a recap. Vertical motion in the air column. Satellite-based shortwave radiation map showing clouds and fog even at nighttime. And the water vapor map, where if your Doppler's unclear, well, the water vapor map will deliver you from that lack of clarity. Anyway, we're out of here. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.